Pemberton. He has been at Cedar for a long time, but he has also contributed a lot to a lot of standards in the web area, notably X standards, W3C and casting style sheets, X forms, XHTML, etc. And today he will talk about why X forms is the way forward to develop web applications.
Okay, yeah, so I'm a researcher at CWI. I also helped design ABC, which was the basis for Python. At the end of the 80s, I helped design a system that you would now call a browser. And as a result, when the web came along, I knew how it worked, and so I organised workshops at the first web conference in '94. The rest of my group went off and formed the first Dutch internet company, and now they're stinking rich and bored at home, and so it serves them right. So I chaired a lot of the initial workshops at W3C, and then ended up chairing for my sins the HTML working group for the best part of the decade, which makes me co-author, as was said, of a whole bundle of standards. So I want to talk about X-forms, which was originally designed for forms, to replace the forms in HTML forms. The first version did roughly that, but thanks to its generality, we realized that with just a little bit more generality, you could do much more with it. And so we did that. We made version 1.1, and now we're busy working on 2.0, which I'll be demonstrating later. So, yeah, how can a form standard be used for applications? Well, it's because it's got input, it's got output, it's got a Turing-complete processing engine, and that's all you need for an application, basically. So it may not look like a form, but actually all it's doing is taking input and doing something with it and outputting something, and it doesn't look like a form, but that's what a form does. So the executive overview of this talk is that we've now got lots of experience with X-forms, and we've found that it gives you about a 10-fold decrease in the time that it takes and the cost that it takes to produce an application in comparison with traditional methods. For instance, a large company that doesn't want to be named because it doesn't want its competitors to know has tried it for something that it's been doing for a long time. It makes huge machines, room-sized machines. It's not ships, but think about the control of a whole ship that are built one-off, and so each one has its own design and its own needs. And traditionally, the user interface alone needed 5 years using 30 people. So 1 year they tried it with X-forms as a pilot, and it became 1 year with 10 people, including the learning phase. So in other words, they've saved $14 million, euros, pounds, it doesn't really matter, and of course 4 years. So in other words, it was a big win for them. Another example is a company where the manager was told he ought to be using X-forms, and so he decided to get his JavaScript people and his X-forms people and say, right, I want you both to do it. I want you to go away for 2 days and tell me, give me the estimate of how long you think it will take to make this application. 2 days later, the JavaScript man came back and said, I need more time, I need another 30 days to work out how long it's going to take. And the X-forms man said, I've already done it. So how can this be? Well, the answer is that since the 50s, computers have become incredibly cheap and incredibly powerful, and yet we're still programming them with programming languages that are essentially stemming out of the programming languages designed then, which were to make the computer do work as fast as possible, so to take work off the computer. But in fact, most computers spend most of their time idle. I mean, while I was writing these slides, this is my computer. There's a lump at the end when I take the screenshot, but it's essentially idling. So what we can do, and this is what X-forms does, it takes the load off the programmer and puts it on the computer where there's spare power over. In the 70s, computers were becoming 2 orders of magnitude faster than in the beginning period. But programmers weren't becoming faster. And all of a sudden the cost of software was starting to hurt. And they started talking about the software crisis. The Department of Defense in America did some research and discovered that 90% of the cost of software was debugging. Now, interestingly, around the same time, Fred Brooks, in his great book, The Mythical Man Month, which is worth reading even though it's 25 years old now, he reported that over a large number of projects that he'd managed, including huge ones, including small ones, that he found, and regardless of which programming language was used, he found that the number of bugs in a program is not linear to the size, but quadratic. The number of bugs is proportional to the length of the program to the power of 1.5, which means that if a program is 10 times as long, it's going to cost 30 times as much to make. or the other way around, if it's 10 times shorter, then it's only going to cost 3% of the cost. So you can say that there's a verbosity gap, that as the program gets longer, the cost of producing it becomes more than linearly more expensive. So this is the X1's advantage. The main reason that X1s can produce such savings is because what you specify is not how to solve the problem, but what has to be solved. So there's far less administration to worry about, which means shorter programs. And how much shorter? Well, a correspondent in Denmark had to translate a large corpus of JavaScript applications into X1s, and he said that the X1s are generally about a quarter of the size, which, according then to that graph, that means the cost should be reduced by 2/1/8, which is about an order of magnitude, and that's what we've been seeing. So this isn't a tutorial in Xforms. I'm only going to show you just tiny little things, give you a taste of it, but I am going to give you a demonstration so you can see it working. So there are two essential parts of Xforms. Firstly, is that there's a split between the model and the user interface. The model is where all the data is kept, and its related logic, like the types, the restrictions, date of birth must be earlier than the date of death, initial values, relationships between values, for instance, total price is the number bought times the unit price. And then the body of the document is then binds controls to the data value. So there's a strict split between the data and the controls. And by the way, the data can be populated beforehand, can be done locally, or it can be done over the internet. You can get your values from all sorts of places, as you will shortly see. The other essential part is that the controls of the form are not presentation-oriented, but they're intent-oriented. That is, they say what they're meant to do, but not how they're meant to look. In HTML, for instance, you've got a number of controls like radio buttons, menus, and so on, which actually do the same thing. They just select one value from a list. But in Xforms, the control just says what it's meant to do, and then the presentation layer decides how to present that. And that means that it's very much easier to use a form over different sorts of devices, even very different modalities such as voice, because you haven't embedded a presentation in it, you've just embedded an intent. And also, as you will shortly see, the labels can be populated for local or external sources, which is great for localization and multilingual environments. So just to give you an example of an intent-based control, these are actually 3 times the same control, but just presented differently. And so you can see that if I select one of these, they all change simultaneously because they're all bound to the same value. And so the system just ensures that anything that's bound to the same value gets updated. So I've just used 3 times exactly the same command and used 3 different stylings in the CSS. Yeah, I said input and output, so if I say red, bold, then you can see as I'm typing, the output is done simultaneously, so there are constraints being updated all the time as you're working. Controls can adapt, so here it said all I'm doing is typing into something that says it's a date, but I haven't actually given it a type anywhere. But if I add to this form and nothing else, just the information that we're talking about a date here, then the control just adapts to that data type. So all of a sudden I can now, without having to do any work, I automatically get a date. And furthermore, if I go and type something here which isn't allowed, then it immediately complains that this isn't valid and stops you working further to fix it. Controls can be pre-populated from all sorts of places. So here's an example. I've pre-populated this with a language file. So if I say I'd rather have it in English, then everything switches over to English, including the values of the labels here. So if I then go to French, then it says masculine instead of male. So this is all just happening automatically. I haven't had to do any work. I just said here are the labels, and it ensures that the labels match up to my choice in the language field. Deployment. There are a whole bunch of different methods of deployment. I still have time to tell you it. There are native, that is running on the machine itself, client side, which means running within the browser, and there are server sides, which sort of does a translation at the server and sends it down to whatever device you're using, which is actually very good for multi-device deployments, because the server can look to see what device you've got and send you a suitable version of the form. Here's a recent picture of the iPhone implementation, which was actually very chic. What this guy has just done is just turned it and got a completely different display. That you can look at your data one way or another way, just depending on how you turn the phone. There are a number of open source implementations, blah, blah, blah. There are a large number of enterprise implementations, not necessary to buy, but used in-house. Xerox, IBM, OpenOffice, JDU, and the last four are actually all Dutch or Belgian. So there seems to be a lot of support in the Benelux for exports. Enormous number of users. I just recently learned that the Dutch weather service KNME is completely run on Xforms, which was a delight to hear. But there are UK government sites, Dutch government sites, EMC, the entire British insurance industry, US Navy, blah, blah, blah. It's very widely used. But now, to get onto the demo, which is the fun of it. Okay, so what I'm going to do is show you how to do a mapping application with Xforms, just to show you some of the power. So, if you want to have an image in an Xform, well, there's the URL within the data. This is the data. You've got to think of this data in the head of the document. And then in the body of the document, you can output it with output ref equals URL. So then you get something that looks like this. But if you add to the output media type equals image / star, then all of a sudden it gets dereferenced and displayed as an image. So this is from OpenStreetMap, and I'm required to say that it's licensed under the Open Data Commons Open Database License. So now we've got that, we can have a look at the structure of the URL. An OSM URL is made up of the site, the zoom, the x, the y, and then .png. So I can put that into the data, the site here, the zoom, 10, x and y coordinates. And the URL I haven't filled in yet because I do a bind to calculate the URL just by concatenating all those bits with the slashes and the .png. And now we can also, that means that we can also input the different parts, for instance, the zoom, the x and the y. So now it's the same thing, except that now if I change this 6 into a 5, for instance, then, and tab it, then all of a sudden I get a different tile. But I haven't had to do any work because the system has just made sure, has seen that the URL changes, and so therefore has updated the new version of the URL. Well, if this doesn't make you excited, then you're in the wrong business. So, changing the values like that is hard work. So I've just added a single trigger for each value, so that, for instance, now I can just go click left, click right, click down, and you get the relative map tiles. The problem is, though, if I zoom, then it doesn't work. Oh, well, that's because there is. So here we just get water, and that's because at each level of zoom, you get twice as many tiles at that level, and so the coordinate system basically changes at each level. So we're going to fix that. We're going to fix that by keeping our position as a position on the whole world, and then using that position with the zoom to work out which tile we want. So this is all I had to do extra. I've a scale which is 2 to the power of 26 minus zoom. 26 is the 18 levels of zoom plus the 256 pixels of each tile. And then I calculate x and y by just dividing the position in the world that we're at by basically by the tile size. So now, again, this works just the same, but if I zoom out, then all of a sudden we're zooming out into the right place. The problem is, though, now you'll see, this tile is, by the way, the tile that we are on. We're here somewhere, right? And what you see, though, is as we zoom in, that position sort of bounces over the tile. And there's a reason for that, which I can best demonstrate with a diagram. But if you've got a tile, that inner one, one with the word zoom over it, and you're roughly in the middle, then when you zoom into it, you zoom into one of the four quarters of that tile, and all of a sudden the position that you're looking at is in a completely different location on the tile. Now that means that when you're zooming in, it's sort of bouncing over the screen, and it's not very useful, because when you zoom in, you're expecting the place that you're looking at to be in the center of the screen. So how do we do that? We create a 3x3 array of tiles, with the middle one is the one with our location on it. And then we put a porthole on the top of it, and we sort of shove that array around, so that the center point is always in the center of our porthole. So the calculations are very easy for that. We calculate the offset of x and offset of y, and then we create a bit of CSS that actually does it for us. We put the style on a div, so that the thing underneath this porthole then is moved around, but we're not aware of that happening. So as I zoom in now, our location stays in the middle, and there we are. Now I can imagine you're saying, don't quite get it, so I'm going to show you it happening. I'll zoom out a bit here. So this bit here is our porthole, and behind it is the 3x3 tiles that contain our location, and I've drawn lines where the tiles are so you can see them. And so now as I zoom in, you'll see it sort of boinging around the screen while it keeps our location central on the screen. How am I doing for time? Very well indeed. Great. Okay, so, but of course, you don't want to click buttons to zoom around and move around. What you want to do is use the mouse. Okay, well the mouse isn't integrated yet fully into XForms, but it's very easy to do. So we create data for the X and Y coordinates of the mouse, and then every time the mouse moves, we catch the event and just store the location of the mouse in that data. So all of a sudden now, I've got live data. I'm just moving the mouse around, and I've got live data up there, which I can now link to, so that every time the mouse moves, I can do something with it. The next thing I want to do is also have the state of the mouse, whether I'm clicked on the button or not. So I save that in my data up there, and I catch the two events that says whether the mouse is up or down. So now I've got full details, live data of what the mouse is doing. I've got its position and its state. So I'll show you linking to something like that. You'll see now the mouse is a different shape, or I hope you can see it's a hand like this. What I want is that the mouse cursor changes when I'm clicked on the button. So how do I do that? Well, I say that every time the state changes, so if the state is up, I want the pointer, and if the state is down, I want the move value. So when I click on my mouse here, you'll see, hopefully, that the shape of the mouse is changing. And all I'm doing is watching the data. I'm just linked to the data in the instance. I'm not having to do any more work than say, there is this relationship between the two, and the system ensures that it's kept up to date. The last thing I want to do then is, when I'm dragging, I want to save the distances that I'm dragging. So I save the start position, the end position, and I calculate the move from the start to the end. So whenever the mouse goes down, I save the start position of the drag. This just gets calculated all the time, but if it's down, then it just saves the end state continuously for me. And then, again, continuously, the move is just the end minus the start. So when I click here, you'll see the move, you can see the endpoint changing, and therefore the move coordinates changing. So now we have everything that we need to be able to do a drag interface to the map. So now the position at the center of the map now depends not only on the position that you want to be, but also plus the drag. So that's all I'm doing here, is I'm calculating the last x and y that we were at, minus the x and y of the move, times the necessary scaling for the level of zoom we're at. And the other thing is that when the mouse goes up, then I have to reset the move. So, the moment of truth, I click and I move, and the system's doing it all for me. I have to do no work here because it's all just a bunch of constraints that's being kept up to date. I've also added a mouse wheel here so I can zoom out and zoom in easily. And my last slide of the demo is that once you've got this, then there's all sorts of things that you can do really easily. For instance, there are lots of different maps. All I have to do is to put a select in that selects which of the maps I'd like to see. So for instance, if I'd like to see the cycle map or the transport map for the Netherlands, then I just have to select which site the maps are being selected from, and it all gets done for me automatically. So if I zoom in now, I zoom in somewhere different. So, and I can have a home button that takes me back to where I was. And those are all very, very simple things. So, that's the end of my demonstration. So my conclusion is that you've just seen a mapping application written in, well, a little more 100 odd lines. There's not a single while loop in there. In fact, Xbox doesn't even have a while loop. In the 50s, computers were really expensive. They were really slow, and programmers were as good as free. Well, you didn't buy a computer in those days, you leased them, and you usually got a bunch of programmers free as a sort of sweetener to the deal. Now it's exactly the other way around. Programmers are really, really expensive and slow, and computers are as good as free and very, very fast. So it's time to make programs fast as well. And I believe that declarative programming like that is one of the part of the routes to the future. Thank you. Slides are already online. If you don't know how to find them, then you should be considering a different career. And there are a number of resources like tutorials, overviews, and so on that you can get from there as well.
Thank you, Stephen. Nice and time. We have time for questions. Davey, I saw you first.
You have the concept of server run Xforms and client-side Xforms.
Yeah.
So